Hello and welcome to today's video where I will show you how we did the whole connection of the Octave water meter. So this is our development version of our device. It's M-bus, and we've got M-bus line connected into the Vago clamps, and here is the water meter. Yeah, we can see approximately the value on the screen, and there is a flow which is simulated, so the numbers are changing a little bit, but this is approximately what we have there. So what I will do now is that I will connect into the configuration mode into our converter, and fastest way how to get there is to reset and connect. And now I will read back the Lua script which we have there, and actually the Lua script is not so long, so we've managed to fit inside also the JavaScript formatter for the things stack or the things network. So this is the Lua script. Data from Octave devices will be transmitted at port 102. It's possible to remotely set up also a list of devices which will not be processed in the Octave way, but their M-bus data would be split in multiple messages, but by default this is disabled. Acknowledgement of messages is by default disabled. You can enable it here. If you enable it, then every transmitted LoRaWAN frame will require acknowledgement from the network server, and that's about it. Here's some initial delay. It's the time for which M-bus line is enabled before the actual request for the data to Octave is sent. And there is, it's good to optimize this, but there is 5,000 to have a good compatibility for now. So list of Octave devices is there is just one device, and we are using broadcast. It's possible to manually preset here the addresses in case you have multiple devices connected, but you can do this also over LoRaWAN remotely, and it's stored in the device persistently. You can also have filtering. This applies only to devices which are sent at port 100, and the list is here, and it is by default disabled. We keep these features there because we have based this Lua script on an existing Lua script, and we try to predict what could happen. For example, in case you would need to connect on the same M-bus line a device which is not Octave, and you would like to read them out so that you have the possibility built in. The period is 15 minutes. Here you can change it if you want to have wake up every 1 hour or every day. You can put here the interval in minutes, and that's about it. Here is a list of VDIFs which we try to filter out from the payload of the meter. If some of the group would not be available, it should not happen, but in case it happens, we fill the missing part with FFs, and the parser is compatible with that. So that's it. We don't need to go into details. What is important for us now is this part, which contains the JavaScript parser. So I will copy it like this, and I will go to the things stack. We have our own instance of it, and here we go to payload formatters. We need to select custom JavaScript formatter for the uplink, and we paste there this code. Okay, this was not the latest version, there must be division by 1000 here. It was the very last missing part. Okay, so it's like this, and we can save it by the button here, save, and it's saved. Now we will go to live data, and I am still connected to my device, so I will connect only to see the serial prints, but I will not block the device from normal functionality. So I will disconnect, connect in just serial view mode only, and soon the device will start running, and we will see printing here, and we can observe the data. Oh, okay, join here, join, accept, it is joining, and yeah, list of devices to read is here. It's printed upon boot, and it sends, yeah, after boot it sends this startup LoRaWAN message, so we can ignore it for a moment, but it would be also possible to parse it. There is dev EUI and other information about the device there, and after that, after the boot is done, yeah, we can ignore this part actually. After the boot is done, now the periodic action happens, and this is every time the device wakes up, this part happens. And as you can see, this is the full frame, which is read from the M-bus. Then we apply filter one by one, and these are fragments of what is extracted from the original M-bus frame. And then this part is the actual payload, which is sent to LoRaWAN. So if I copy it like this and I put it in the parser here, I can test it, but you can also see that we have already received it here, and you can see it's parsed like this. Okay, so you can now remember these values, and I will quickly try to show you on camera what's the current state on the water meter, but it is flowing quite fast. So you can see it's 11,583.110, and flow is 15.75, and here you can see that the data is matching. Also, current date and time is matching. It's 11:32 now, but I think this is time of the sample actually. So it's not current time of the device, but instead it's time of the sample. Here is the serial from the device, the flow, positive and negative flow value, which has already gone through the water meter. And now the device is in sleep. If you want to make it send the data more frequently, what you can do, you can press the button, and when you press the button, you force the device to read out the value again and send it again. So if we wait a bit, it waits 5 seconds before. If it's woken up by the button, it waits for a connection of the configuration interface. So that's why there was an extra delay. And here we wait 5 seconds after M-bus is turned on, because the devices, M-bus meters, they require that this initial delay. And we can see that the values changed a little bit and it's moving. I have copied the value from the serial console, and if you also put it here, you can test the decoder like this by clicking, and you can see the output here in JSON. So after that, I guess you will want to resend the data from the Think stack via MQTT or HTTPS, but this is not scope of this video. So thank you for watching, and see you next time. Send me an email at novak@acrios.com if you have any question. Bye, or call me.